Okay, so we have another example here, and I'm throwing in a new technique as well, generating a random number, which is an easy technique, but we are playing a raffle for the student life. And today's prizes are, okay, raffle tickets. I'm going to generate a number 1 through 100, some random number. Numbers 1 through 50, they get a cheap USB thumb drive. Numbers 51 through 90 will get a $25 gift card for the college bookstore. And then numbers 91 to 100 will get a rare Italian sports car. So it says press enter to generate your ticket, and good luck. So I'm going to press enter. We'll see what I get. What I've done, another thing is I've delayed the program for 5 seconds to make it look like there's suspense. So in this case, I got the thumb drive, and I mean that's obviously the highest possibility. And we'll look at the code in just a moment. I'll try one more time. I'll see if I get a different prize, but I'll hit enter there. Again, the 5-second delay. Okay, that's a little better. So let's take a look at the code. So really, right off the bat, I have generated a random number, and this is easy. You use the math object get random number method, and let me see if I can get that. Okay, hang on here. Yeah, let me pull this up by the IntelliSense. So get random number. So this is look over here on the right. It says all you have to supply this method is the max number. So, and it'll give me a random number between 1 and the specified max number. So if I want 1 to 100, I will just plug in a 100 there. Okay, pretty easy. And then I'm just laying out the menu. Okay, at the end, I ask them to press enter to generate the ticket, and I'm just absorbing that enter key with the text window.read. And this pauses the program too. The read method will pause the program because it's waiting for the user to enter something. Okay, and then I'm telling them I'm generating your ticket now, and I'm delaying the program by 5 seconds. So that's program.delay, the program object's delay method. And then the argument that you provide is in milliseconds, okay, so 5,000 milliseconds. All right, and then now we're into the decision structure. What did the person win? It depends on the ticket number. If the ticket number is less than or equal to 50, we know it's going to be at least 1 through 100. So if that's less than or equal to 50, then they get the prize. I created a prize variable, and I'll set that to the cheap thumb drive. Now, this middle area is a little more complex because we're isolating a range of values. And, we really need a compound condition here, because in order for a number to be in that 51 through 90 range for the gift card, the $25 gift card, that's the 51 through 90 range. You really have to set up a compound condition to isolate that range. A number that is in that 51 to 90 range is greater than 50 and also less than or equal to 90. All right, so we're using the logical and to set up that compound condition. Very common when you need to isolate a range. Okay, so if they end up in this range, then we're going to make it the gift card. And then, at this point, if I reach the else clause, at this point it's got to be the sports car. Okay, because as I said, it looks for a true. It starts at the top. When this is executing, it's going to start at the top, and it's just looking for a true. If this is not true, it moves on to this one, and it evaluates that whole thing. Now, both of these parts have got to be true. If it's a compound condition, and with the and, both of these conditions have got to be true in order for the whole thing to be true. And if it is, like you saw when I ran the program the last time, I did get the gift card. So that layer of the sandwich executed. Or else, if we've made it this far, None of the above were true, so we must have the sports car. And that's it. So again, just very simple logic. We have a 3-layer sandwich with 3 possibilities because there are 3 categories of numbers and three prizes to give away.